Welcome all to today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject that I am covering in my lecture series is Embedded System, that is open elective with subject code KOE 062. The topic that I am covering in today's lecture is CAN bus, that is controller area network, and that is the serial communication protocol. We will see how this CAN bus protocol works. Now, when we talk about the controller area network bus, this is the method of communication between electronic devices embedded in a vehicle. So, basically in the modern era, we come across many devices embedded in our personal car, which has been made, which has been targeted for our safety, for our convenience, for our ease of travel. So, all these devices that we see embedded in our car, in our personal car or any of the automobiles we are talking about. So, all these devices are interconnected with each other. So, how they are interconnected with each other? That is done through CAN bus protocol, such as the engine management systems, active suspension, central locking, air conditioning, airbags. All these are very common devices, or we can say very common features which we come across and which we also as the customers target when we go to purchase a new vehicle. So, what are all these and how they are made possible? What is the communication protocol behind these devices, behind the working of these devices? So, all the answers to all these questions is the CAN protocol. The idea was initiated by Robert Bosch in 1983, and that idea was to basically improve the quality and safety of automobiles, enhancing automobile reliability and fuel efficiency. So, all these were the targets, were the aims behind this idea, behind the CAN protocol. It was first released in 1986, also provided advancements in communication. This was significant because developments in the electronics and semiconductor industries at the time led to the new technologies, but also challenges for engineers in the auto industry. So, this is how CAN protocol was commercialized, CAN protocol was in demand, it came into demand. For example, electronics offered more features and complexities, including the ability to communicate between the devices. Auto engineers were often given the task of incorporating such devices, ensuring that they work without errors. So, CAN protocol facilitates all these things, that the various devices embedded inside a automobile is able, all those devices are able to communicate with each other with ease, without any errors. The CAN simplified the process, whereby different electronic modules could communicate with each other by using a common cable. How it is being done? Let us see. What was the need for CAN? A vehicle contains a network of electronic devices that share the data and information with one another. For example, a spark ignition engine requires a spark to initiate the combustion chamber. Timing is important here, because to ensure this occurs accurately, it communicates with the vehicle's engine control unit, which chooses the ideal time for an ignition to provide the power and fuel efficiency. So, this is how both the devices are working together. Another example of communication between the devices includes that of the automobile's transmission control unit. It automatically changes a vehicle's gear in relation to its speed by using the data from the engine control and various sensors in the system. So, this is about the automatic car. So, automatic car is very much in demand nowadays. What is happening in that? That the gear change takes place automatically without manually doing it. How is it possible? Because it is being controlled, it is being connected to the speed changing device and to the sensors. So, as soon as the speed of the car changes, the various sensors comes into play and they control, they initiate or they guide the gear changing mechanism, and this is how the gear itself changes automatically. So, this is how the various devices inside a car are connected to each other, and this is how they are controlling each other's actions, and this is how we are getting an automatic car with which is having all the facilities, which is having all the ease of travel. Devices must be equipped with hardware and software to properly communicate. So, as we all know that where two devices are communicating with each other, we obviously know that they are having the hardware as well as the software embedded in them. Before the CAN was used in the vehicles, each electronic device was connected to another via wires, or more specifically there was the point to point wiring. So, this was getting more and more complicated with the special add-on features that those were incorporated inside the vehicles. So, this worked effectively enough when the functions were basic, as I am discussing that when there were the basic functions, this was okay. This could have been done using the wires, but when the functions enhanced, when the multiple functionalities was added on to the car, to the vehicles, then how this was possible? This was not possible. But one of the major problems for the automotive engineers as electronics advanced was linking the ECUs, that is the electronic control units of different devices, so that the real time information could be exchanged. So, basically what was happening that there were the different electronic control units for each and every device, for each and every panel. Now, the major problem was how these electronic control units were communicating with each other. So, this was to be managed. The CAN protocol was designed to address this problem. The protocol set rules by which electronic devices can exchange the information with another over a common serial bus. So, basically it is having the common serial bus, it reduces the wiring connections and the overall complexity of the system. Every electronic device has an ECU or the MCU, electronic control unit, which with its own set of rules to share and transfer the information. So, every device which we are talking about, which have been embedded in the automobile, in the car, in the vehicle, each is having the ECU, or we can say the MCU, that is the microcontroller control unit, which is having its own set, and this is how it transfers the information. Now, this is how the various facilities, various functionalities are connected to each other. Here the engine control, lighting, power windows, power seats, air condition, power locks, airbags, anti-locks brakes, active suspension, transmission control. So, this is the scene of that particular era when the CAN protocol was not in use, and all the devices, all the functionalities inside a vehicle were connected using point to point connection, that is using the wiring. So, this is the example of wiring connection in the any vehicle. Now, when the CAN is implemented, so all these functionalities are connected to each other through the CAN protocol. So, this is the common bus, and every device is having its own CAN protocol, and this is how each and every devices are connected to the every other devices through the CAN protocol. So, this CAN protocol was the standard technology of the time, that was the asynchronous transmitter and receiver, was unable to support the multi-domain communication. So, after this the CAN protocol came into use, because that was the earlier technology, that was the asynchronous transmitter and receiver. This was not worthy enough to support multi-domain communication. So, the CAN protocol came up and with the better solutions to support this facility. So, a domain is a group of electronic devices that have similar requirements to work properly in the system. For example, CD or DVD player, GPS and monitors display from a single domain. Similarly, dashboard, air conditioning system or climate control, wipers, lights and door locks, they form another domain. So, these two domains, suppose you want to connect all these two domains or all other domains to each other. So, this is made possible using CAN protocol. Electronic devices in a vehicle can be classified under different domains, and CAN facilitates multi-domain communication, which is a great help to auto engineers. How the CAN is implemented? So, it is having a set of rules for transmitting and receiving messages in the network of electronic devices. CAN was developed with a specific focus on the auto industry, but its architecture and advantages have led to several other industries such as the railway, aircraft and medical sectors to adopt the protocol as well. So, every electronic device, or we can say every electronic device is termed as the node, which wants to communicate via the CAN protocol, is connected with another through a common serial bus, which allows for the transfer of messages. For this, the data exchange to occur, the nodes first require the necessary hardware and software. This is how a CAN protocol connected nodes look like. So, nodes are the device. So, this is how the node A, node B and so on, these are all connected to the CAN bus, which is a logical bus. So, in this way, suppose node A, node N, node A is ABS system, node N is EMS system. Here is the host controller with each node, here is the CAN controller with each node, and then finally there is CAN transceivers, and after that there is the twisted pair cable, which is basically used, that is the CAN bus, and used to transfer the communication, communicating data between the different devices. When we talk about the data transmission, so unshielded twisted pair cable is used to transmit or receive the data. It is also known as a CAN bus. So, this is how the unshielded twisted pair cable look like. So, basically there are two lines in this wiring, that is CAN H and CAN L, which are also which are used to transfer the data. These transmission occurs due to the differential voltage applied to these lines. So, to these lines is applied the differential voltage, and due to the difference in this voltage, due to this differential voltage, the communication happens. So, the CAN uses twisted pair cable and differential voltage because of the environment. Since we know that the CAN protocol is used in the vehicles, for example, in a car, motor, ignition system, and there are many other devices which causes the loss of data and data corruption due to the noise. So, the twisting of these two lines reduces the magnetic field. So, since we are using the twisted pair cables, this reduces the magnetic field, and therefore, this reduces the data loss. Also, the bus is terminated with 120 ohm resistance at each end. All these features makes possible the data transmission, the information transmission, information exchange between the various devices without the data loss. So, when we look at the CAN protocol, we are having the three basic elements. First is the host. A host is a microcontroller or the microprocessor, we can say, which is running some applications to do a specific job. The host decides what the received message means and what message it should send next. So, this is the role of host. CAN controller deals with the communication functions described by the CAN protocol. So, it converts the messages received from different nodes as per the CAN protocol, and which are then transmitted via the CAN transceiver over the serial bus. So, this is what is happening using the CAN controller. Now, finally, what is the role of CAN transceiver? CAN transceiver is responsible for transmission and reception of the data on the CAN bus. So, as the name is suggesting, it is also responsible for receiving as well as the transmission of the data. So, it converts the data signals into the stream of data collected from the CAN bus, and the CAN controller can understand. Now, finally, when we talk about CAN protocol, it does not follow the master slave architecture. It means every node has access to read and write data on the CAN bus, When the node is ready to send data, it checks the availability of the bus and writes a CAN frame into the network. When we talk about the CAN frame, this is how the data is transmitted. This is the actual data that is being transmitted. So, it is a structure that carries a meaningful sequence of bits or bytes of data within the network. We will see how the CAN frame looks like. So, before discussing the CAN frame, I must tell you that the CAN protocol is of two types, address based and message based. In address based protocol, the data packets contain the address of the device for which a message is intended. And in message based protocol, every message is identified by a predefined ID rather than an address. So, typically the CAN frame that we are discussing, it is a message based protocol. So, the CAN transmitted frame is typically a message based and it is a packet of data that carries information. It is made up of 10 bytes of data which are organized in a specific structure called a frame. All nodes using the CAN protocol receive a frame, and depending upon the node's ID, the CAN decides whether or not to accept it. If multiple nodes send the message at the same time, what will happen? The node with the highest priority receives the bus access. So, this is how the priority arbitration takes place in CAN protocol. The lower priority nodes must wait until the bus is available again. So, this is how the CAN frames are received according to the priority. This is the CAN frame. It has many elements inside it. So, first one is bus idle, that is bus is idle initially. Next is SOF, that is the start of frame, which indicates that the new frame is entered in the network and it is of 1 bit. Next is the identifier, that is ID, a standard data format defined under the CAN 2.0a specification. So, this is the CAN standard which we are discussing. It uses an 11 bit message identifier for arbitration. The standard CAN 11 bit identifier establishes the priority of the message. The lower the binary value, the higher will be the priority. So, this is basically 11 bit message. RTR is remote transmission request, which defines the type of frame, whether it is the remote frame or the data frame, and it is also 1 bit. A remote frame is what? It is a broadcast message that is being transmitted from the transmitter to the specific node in order to request the data from the node. Error frame may be transmitted by any node and that detects a bus error. Overload frames are used to introduce additional delays between the data or remote frames. Control field, it is a user defined field, and under that IDE comes. IDE bit is a control field, stands for identifier extension. Here the IDE, that is a control field having IDE, R and DLC. We will discuss all these one by one. Under the arbitration field was identifier and RTR, as I have already discussed. So, IDE is identifier extension or dominant IDE bit. Dominant means a 0 level IDE bit defines 11 bit standard identifier, whereas the recessive, that is the 1 IDE bit, defines the 29 bit extended identifier. So, this is what is the role of IDE. DLC stands for data length code. This will tell how much is the length of the data to be transmitted, which defines the data length in bytes. So, in CAN the data length can be up to 8 bytes. So, this DLC will tell the exact length of the data bytes in bytes. So, it is of 4 bits, which will define the length of the data in terms of bytes. When we talk about the CRC field, the data frame also contains a cyclic redundancy check field of 15 bits, which is used to detect the corruption if it occurs during the transmission time. So, what is exactly happening, that the sender will compute the CRC before sending the data frame. Also, receiver also computes the CRC and then compares the computed CRC with the actual CRC which was received from the sender side. If the CRC does not match, it means the receiver will generate the error signal, and it means that the error has been introduced in the transmitted data. So, this is how the CRC field is useful in detecting the errors. Acknowledgement field, this is the receiver's acknowledgement. In another protocols, a separate packet for an acknowledgement is sent after receiving all the packets. But in case of CAN protocol, no separate packet is sent, it is just a bit which will denote the yes, the data has been successfully received. End of frame, it stands for containing 7 consecutive recessive bits known as the end of frame. So, the 7 consecutive recessive bits, that is the 7 consecutive ones, will denote the end of frame. When we talk about the applications of the CAN protocol, it was basically designed to target the communication issue that occurred within the vehicles. But later on, due to the features it offers, it is used in various other fields. Following are the applications. Let us see these applications one by one. Automotive, that is the passenger vehicles, trucks, buses. Electronic equipments for aviation and navigation. Industrial automation and mechanical control. Elevator and escalators. So, these are also the CAN protocol is used in these elevators and escalators also. Building the automation. So, when we want to automate everything within a building, so then also the CAN protocol is very much useful, because CAN protocol basically what is it is doing, it is connecting the different devices using a common bus. Medical instruments and equipments, marine, medical, industrial and medical fields. So, what is happening, as we can see that initially the CAN protocol was designed to solve the problems inside the vehicles, to connect the devices which were embedded inside the vehicle. But we can see that it is being used in other fields also. So, this is how the CAN protocol became popular. When we talk about the CAN benefits, first of all, it is simple and low cost. Electronic control units communicate via a single CAN bus instead of via direct complex analog signal lines, reducing errors, weight, wiring and costs. So, initially, as we have already discussed in the previous slides, that initially CAN protocol was having the wiring between the various devices. So, the communication between the various devices was based on the point to point wiring, but later on this wiring was all replaced by the wireless connections. So, all devices inside a vehicle can communicate with each other without using the wires with the wireless communicating system. So, this is how with time the system became simpler, system became cost effective. So, the cost of the wires, which was the main cause of concern earlier, it has been removed. So, this is how it became simple and low cost. It is fully centralized. The CAN bus provides one point to point entry to communicate with all the network electronic control units, enabling central diagnostics, data logging and configuration. So, this is how this is fully centralized, that it is centralized in the sense that it is having the common bus, and the devices which want to get connected to other devices, which want to connect the system, get connected to the system, can be easily connected to the common bus. So, when we say it is extremely robust, it is robust because it is robust towards the electric disturbances and electromagnetic interference, ideal for safety critical applications. So, what is happening, as we have already discussed, that this system is very much robust, because the twisted pair cables wiring is being used, and this greatly reduces the data loss, it reduces the interference, because it is offering the less magnetic fields. So, this is how this system becomes robust. It is efficient because they are prioritized by ID, so that top priority data gets immediate bus access without causing interruption of other frames. So, this is how the system works efficiently, that the data that the device which is having the higher priority gets the access of the bus and can easily communicate with the other devices. So, this is how the system works efficiently based on the priority arbitration. So, these were all the benefits of CAN, and in this lecture we discussed about the CAN protocol, its benefits, its working, its data frames, and this was all about CAN protocol. Thank you.